In section 6.1, we're going to be talking about the midsegments of a triangle. So a midsegment is a line segment that connects the midpoints of two lines. So for number 1, it says, in each triangle, M, N, and P are all midpoints of the sides. Name the segment parallel to the one given. So a couple things that we need to note here. We have CD with a line over top. That means that I'm looking at line segment CD. These two lines here, that means parallel. So I'm looking for the line segment that is parallel to CD. So I'm just going to highlight CD is here. So parallel lines don't cross or touch. So I'm looking for my one other line segment that's parallel. So that would be PN. Now, if you wanted to write it NP, that's fine. Make sure you put your line over top to show that it is parallel. So then in problem number 2, same thing. I'm looking for the line segment that's parallel to QS. QS is here. So MN or NM, however you want to label it, is fine. So MN is parallel. Now in problem 3, I'm looking for the length of the missing side. So I'm looking for CD. CD is parallel to ZX. So CD is my midsegment. In order to find the length of my midsegment given this type problem, I need to take the longer piece and divide it by 2. So 16 divided by 2 gives me a value of 8. So the measure of CD is going to be 8. Now in problem number 4, it's a little bit different because it gave me the midsegment, which is here. It's looking for this piece here. So with this type problem, I'm looking for the longer side, so I'm going to multiply by 2, which also happens to be 8. So if I'm going from this to my midsegment, I need to divide. If I'm going from my midsegment to my longer side, then I need to multiply by 2. So problem 5, same type problem as number 3. I'm going to take 18, divide it by 2, gives me a value of 9 because I'm looking for the mid-segment. Now, when you get to problems such as these on the back that have x's, I'm using the same rule. So I'm solving for x. So these two lines here are parallel. I can tell by the markings of my triangle that this is a midpoint and this is a midpoint. So in order to solve for x, the mid-segment is always going to be smaller than the longer side. So in order to solve, I need to multiply by 2. So this is the mid-segment. The mid-segment gets multiplied by 2 in order to solve. So x plus 9 is equal to 4x minus 6. I'm going to add 6 to both sides. So I get x plus 15 is equal to 4x. I'm going to subtract x. 15 is equal to 3x. Then I'm going to divide both sides by 3. So x is equal to 5. Now, in problem 12, similar type problem, but what you need to make sure you note of is that this x plus 6, that's extra information. That's just fluff thrown in there to throw you off. So I'm taking my two parallel lines. My mid-segment piece is the smaller segment, so that's going to be multiplied by 2, is equal to x plus 6. So 2x minus 6 is equal to x plus 6. I'm going to add 6 to both sides. 2x is equal to x plus 12. Subtract x from both sides. So x is equal to 12. Now, when you get to one like problem 13, it asks for the length of LN. So I'm still taking the same approach. However, it's not asking me to solve for x and stop there. I have to plug my answer back in order to find the length. So 2 times x plus 2, because x plus 2 is my midsegment, is equal to x plus 10. So 2x plus 4 is equal to x plus 10. Going to subtract x from both sides. X plus 4 is equal to 10. Subtract 4. X is equal to 6. So now I need to plug this into the problem. So 6 plus 10 gives me a value of 16. So you need to make sure that you read your directions and make sure you're solving for what you need. So this asks for ln, so I had to plug x into the equation for ln in order to solve. When you have ones like at the top where you're just solving for x, you can stop there.